Let us now look at another question of the IIT JEE 2017 advanced paper, and the question says, suppose this symbol here denoted by these brackets represent the greatest integer less than or equal to the variable x, then suppose for this function we have yet another function f of x defined as x into cosine of pi multiplied by x plus gif of x, that is greatest integer function of x. Then for this given function fx equals x cos pi into x plus gif of x, then we have to find for this function at which points is fx discontinuous. So we have been given these 4 points, that is x is equal to 2, x is equal to 0, x is equal to 1, and finally x is equal to minus 1, and we have to check for which of these points is fx discontinuous. Now we know the condition for discontinuity of a function. Now a function is continuous at a given point only if the left-handed and right-handed limits are exactly the same. So condition for continuity is left-handed limit should be equal to right-handed limit at that given point. So we will now examine the left-handed limits of this function and the right-handed limits of this function at all these points. Let's get started with the first point. Well, the first point here is x is equal to 2. So now if we find out limit of this function as the variable x tends to 2 from the negative side, that is we are finding the left-handed limit of this function as x tends to 2 from the negative side. So we will now write down limit of x tends to 2 minus of this function. Now I will replace the value of f of x here, so x will be retained cosine of pi into x plus gif of x, that is greatest integer function of x, and the bracket closes. Well, now note that here because x is less than 2, that is x tends to 2, but x is less than 2 by a very small quantity. However, x is certainly less than 2 because x tends to 2 minus, and whenever x is less than an integer, then the gif of x will return a value that is one integer less. So we know that greatest integer function value of this number which tends to 2 from the negative side is equal to 1. And so we will now replace this x which is under the greatest integer function by the value 1. And so here we can now write this is equal to limit as x tends to 2 minus of this entire function is now equal to, note that this x will be replaced by 2 because x tends to 2 but from the negative side, and so we can now write x can be replaced by 2 here. Then I will now write down cos as it is. Then I will include the bracket which has a pi here as it is, and here there is a x which is 2 here because x tends to 2 minus, and so this x will be replaced by 2. However, this second x is between the greatest integer function bracket, and so this will be replaced by 1 because we are looking at the greatest integer less than or equal to x. In this case x is 2 minus, and so greatest integer function of x will be 1, and so here I will replace this specific bracket by 1. And now the rest is pretty easy. The only thing we now need to do is find out the value of cos of 2 plus 1 pi, which is cos of 3 pi, and we will multiply it by a 2. And so here we will obtain this limit is same as 2 multiplied by cos of 3 pi. Now we know the value of cos of 3 pi is equal to minus 1, and so we can now write 2 into minus 1 will become minus 2. And so we have now obtained the value of limit as x tends to 2 minus of this function is equal to minus 2. So the left-handed limit of this function at x is equal to 2 is equal to minus 2. Similarly, we will now find out the limit of this same function as x tends to 2 from the positive side. So we will now write down, we are looking at limit of the same function, but here x will tend to 2 plus, that is x will tend to 2 from the right hand side because we are finding the right hand limit. Now this x will be retained as it is. Then we will have this function as it is, that is cosine of pi into x plus greatest integer function of x, and the bracket closes here. Now note that because x tends to 2 plus, we have the value of greatest integer function bracket equal to 2. So this will be replaced by 2 because x is tending to 2 plus, and so x is greater than 2. And so here I will replace this x by a 2. I will replace, or rather retain, this cos as it is. This pi will be retained. This x, which is not under the GIF bracket, will be replaced by 2. And this x, which is under the GIF bracket, again will be replaced by 2, because we are dealing with the right-handed limit where x tends to 2 plus. And so this bracket closes. Now note that here we get cos of 4 pi. And we know that cos of 4 pi is same as cos of 2 pi, which is further equal to cos of 0, and it is equal to 1. And so the value that we get is 2 into 1, that is 2. So we have obtained the right-handed limit of this function as x tends to 2 is equal to 2. So we first obtained that the left-handed limit was equal to minus 2, and we have now obtained that the right-handed limit of the function is equal to plus 2. And clearly minus 2 and plus 2 are different, and so we say that at this given point x is equal to 2, the function is discontinuous. So we will now check this option, because at this point definitely fx is discontinuous because the left-handed and right-handed limits are unequal. Now we will continue this procedure and check for the remaining points. Let us get started with the next point that has x is equal to 0. So we are now looking at the point x is equal to 0, and we will repeat this entire exercise for this point. Note that we are again dealing with the same limit, but this time x will tend to 0, and so left-handed limit will mean that x is tending to 0 from the negative side. The function will be unchanged, which is x into cosine of pi into x plus GIF of x. Now to find out this limit, we will observe that x tends to 0 from the negative side, but however x here is equal to 0, so x tending to 0 from the negative side means that here we can replace x by 0, and the moment we replace x by 0, this entire bracket becomes 0, and so we will now get this is equal to 0 into cos of some value which is equal to 0. So in this case the left-handed limit was pretty easily obtained as 0 itself. Now to find the right-handed limit, we will take the same function, but this time we will approach the point 0 from the right hand side. So we write x tending to 0 plus, and the function will be same, that is x into cosine of pi into x plus greatest integer function of x. Now note that again if we substitute x is equal to 0 here, by direct substitution we will get 0 into cos of some finite value, which will obviously give us the value 0, and so we will obtain that for this given point x is equal to 0, the right-handed and left-handed limits are exactly the same, and so the function is continuous. But we want to find the points at which it is discontinuous, and so this is not one of the points at which it is discontinuous. So continuing this exercise further, we will now check for the third point, x is equal to 1. Now the left-handed limit at this point is obtained as limit x tending to 1 from the negative side, that is x tending to 1 minus. Now here the function is again unchanged, that is x into cosine of pi into x plus GIF of x, that is greatest integer function of x. And now here we will substitute the value of x as 1 in this case. So this x will be replaced by 1. Note that the cosine function will be preserved, this pi will be retained, this x which is not under the GIF bracket will be replaced by 1, and this x which is under the GIF bracket will be replaced by 0 because x is tending to 1 minus. So x is less than 1, and so greatest integer function of a value less than 1 will be always equal to 0 because the value is very close to 1 but less than 1, and so the GIF will return the value 0 in this case. Now note that this becomes 1 into cosine of pi. Now cosine of pi is equal to minus 1, and so we write 1 into minus 1, that is equal to minus 1. So we have obtained the left-handed limit of this function as x tends to minus 1 minus as equal to minus 1. And now we will continue the procedure and try to find out the right-handed limit of the same function as x tends to 1 plus. So now we are looking at the right-handed limit x tending to 1 plus. And now we will retain the function as it is, that is x into cosine of pi into x plus GIF of x. And now I have to find this limit. Note that this x will be replaced by 1 as x is tending to 1 plus. The cosine sign will be preserved, then we have a pi here which will be preserved as well. This x will be replaced by 1, but this x which is under the GIF bracket will be replaced by 1 again, because x tends to 1 plus, and so x is greater than 1, a little greater than 1, and so greatest integer function of a value just greater than 1 will be equal to 1, and so we get a 1 over here. Now this comes to 1 into cos of 2 pi, but we know that cosine of 2 pi is same as cosine of 0 and is equal to 1, and so here I will get the value 1 into 1, that is equal to 1 itself. So we have now obtained that the right-handed limit of this function as x tends to 1 is equal to 1. Now note that the left-handed limit was minus 1 and the right-handed limit is plus 1, and so we say that at this point x tending to 1 the function is discontinuous, and we have to check at which point the function was discontinuous. So clearly this is one of the options, because at this point the function is discontinuous. Let us now check the final option, which is x is equal to minus 1. So we have now checked out most of our options and only the last option remains to be checked, which is checking at the point x is equal to minus 1. And now to check discontinuity or continuity at this point, we will again do the same process, that is find out the left-handed and right-handed limits. Now we know that left-handed limit is obtained by whenever we tend to that value from the left-hand side, and so we can write limit as x tends to minus 1 minus. Now here x is tending to minus 1 but from the negative side, and so here we have a x tending to minus 1 minus. The function will be the same, that is x into cosine of pi multiplied by x plus GIF of x, and we will close the brackets correctly. Now note that in this case, here we have x tending to 1 minus 1 minus, so we have x tending to minus 1 minus. In this case, because x is tending to minus 1 from the negative side, x is less than minus 1, and so GIF of a value little less than minus 1 will give us the value minus 2, and so here GIF of x will be equal to minus 2. So here we will substitute this by minus 2, and so this bracket will be substituted by minus 2. Note that the remaining terms will be retained. So here x will be minus 1 because here x is not under the GIF sign. So this x will be retained by minus 1. Next the cosine will be preserved. Then we have a pi which will be preserved. After the pi we have an x which will be replaced by minus 1 again. Then we have this value minus 2 which is GIF of x, and so now here minus 1 plus minus 2 will give us the value minus 3, and so we finally get minus 1 into cosine of pi into minus 3. So we now have this kind of an expression. Now cosine of minus 3 pi is same as cosine of minus pi, which is same as cosine of plus pi, and we know that cosine of pi is equal to minus 1, and so this will be minus 1 multiplied by minus 1, which gives us the value 1. So we've obtained the left-handed limit of this function as x tends to minus 1 from the negative side as equal to 1. Let us now do the final step, that is finding the right-handed limit of this function at the point minus 1. So we write x tending to minus 1 plus. Now the function will be preserved, that is we will retain x as it is, cosine term will be retained, then we have a pi which is also kept, then we have x which is retained plus GIF of x. And now we have to substitute the proper values. Note that x here tends to minus 1, so x will be replaced by minus 1 here. In a similar manner, this cosine will be preserved. Then we will have this pi which will also be retained. Then we have at x which will be replaced by minus 1 because x tends to minus 1 here. Next note that here there is a GIF of x, but x is tending to minus 1 from the positive side, so x is a little greater than minus 1. And because x is a little greater than minus 1, the GIF of x will return the value minus 1 itself. And so here we have a minus 1. Then the bracket closes so that this pi multiplies or applies on both these terms. And now we can easily find the value of this expression. We know that minus 1 will be retained. Here we have a minus 2 into pi, so we can write minus 1 multiplied by cosine of minus 2 into pi. Now minus 2 into pi, cosine of minus 2 into pi will be equal to cosine of plus 2 into pi, which will be equal to cosine of 0. And so here we get a minus 1 into cosine of minus 2 pi, which is nothing but cosine of 0. And we know that cosine of 0 is equal to 1, and so we get this entire term becomes 1, which when multiplied by minus 1 gives us the value minus 1. And so we finally obtain the right-handed limit of this function as x tends to minus 1 plus is equal to minus 1 itself. And so now we've obtained that right-handed limit of this function as x tends to minus 1 is equal to minus 1 itself. So we've now obtained all the required limits, and finally we will check this fourth option, which is x is equal to minus 1. Now note that at x is equal to minus 1, the left-handed limit was plus 1 and the right-handed limit was minus 1. And so clearly left-handed and right-handed limits were unequal, and so we say that the function is discontinuous at this point as well. And so we say that the function that we saw was discontinued at point x is equal to 2, at point x is equal to 1, and at the point x is equal to minus 1. So at all these 3 points, the function was discontinuous. The only point of continuity of this function amongst the 4 options was this b, that is x is equal to 0. And so the final answer is our function is discontinuous at x is equal to 2, x is equal to 1, and x is equal to minus 1. So this is the solution to this question.